Hey guys, so this is my calc video. This is gonna be on volumes of solids of revolution. This is a little bit of ahead of us, but it's pretty fun and interesting. It's pretty simple if you kind of get this kind of weird concept. If you get lost, you can read this Dutch poem, some comments about Interstellar, or pictures of cats based on last weekend's box office results. Pretty fun. So, what are we talking about when we say volumes of solids of revolution? Well, what we're doing is rotating a certain function about the x or y axis, and then we're finding the volume of this three-dimensional object that we're representing. Alright, I'll show you what we kind of mean when we're saying this. Alright. This means that we got this 2D shape, this function of sorts, and if we want to put it around the y-axis, we get this three-dimensional kind of shape. And using a couple of these fancy-dancy functions, we can find the volume of this three-dimensional after shape, quote-unquote, you know. And so, I think the best way to do this is with example. Bloop, bloop, bloop. Alright, so let's say we want to make a ring. Okay, rings are fun, rings are cool. We want them to these certain dimensions down here. Like I want a semicircle, so I have a little semicircle function shape, but I don't want it to be just a sphere, so I want to cut it kind of down the middle when we rotate it around the x-axis. Alright, so then what we're going to be doing is some fun math. Alright, essentially we're making a circle, right? So we're going to be using the area of a circle, alright? And we technically are making dose. We have the radius of the outer circle that we're going to be using, kind of the semicircle function, and the radius of the inner circle, the straight line that we were just using. And then we're going to find the integral of this area, because really we're trying to find the space in between these two circles. And once we do all this math, look at that, we get an answer, right? We got 21.766 cubic centimeters. It's a pretty big ring, but that's how much material we need to use. That's how it's applicable to real life. A lot of factories need widgets, rings, and whatnot. If you want specific numbers, you're going to need to do a lot of calc, right? Here are my sources.